Hello, this video will help explain how to do problem number 7 in chapter 7. Problem 7 involves a railroad car traveling along a track, and then another mass, basically a load, is added onto it. So you had basically a train car that wasn't completely full, and then you added more mass to it. And we're supposed to figure out what the car's new speed would be. So I'm going to have the left mass that I'm drawing be the train car. So M1 would be 12,600 kilograms, and it was traveling at 18.0 meters per second. The load that's dropped onto the train was 5,350 kilograms, and it didn't have any initial velocity in the x direction, so I'm just going to write 0. And when they collide, that means the mass will be m1 plus m2, so you can just write 17,950 kilograms, and we're trying to find out the velocity. Alright, just like problem 6, we're just going to take the diagram we have, make it the equation. So you have m1 v1 initial plus m2 v initial. Oh, I did that backwards. 2 initial. It really doesn't matter. I'm just trying to make it so it's consistent for you guys, though. So if you are in the habit of writing it v initial for the second object, v initial for the final object, or for the first object, that's fine. But just make sure you're consistent. Okay, so I'm going to do the object, and then I'm going to write final or initial afterwards. And then that would equal the mass times the velocity. I have to divide the velocity over, so I'm going to get I have to divide the mass over so I can get the velocity isolated. M1 V1 initial plus M2 V2 initial, all divided by the combined mass. So V would equal 12,600 kilograms times, I'm going to say to the right is positive, so that's a positive 18. A positive 18.0 meters per second. Now if you did this, if you said this is all 0, so you can cancel out, that's fine. You would just end up dividing this by 17,950 kilograms, and you get a velocity of a positive 12.6 meters per second. Keep in mind this problem does have 3 sig figs, so you need to do a positive 12.6, not 13. Okay, so practically identical to number 6, just a different number of sig figs for this problem. Alright, so that's it for this.